Warning: the following video goes deep into Exchange documentation and C++ code when analyzing a viewer's quant trading-related project. If you have the attention span of a goldfish, leave now. Otherwise, you're in the right place.
What's up, guys? Coding Jesus here. Guys, in today's video, we are going to be doing a code review of a member of my Discord community. We are going to be going over high level and then drilling down more detailed into his code. Now, this Discord member in particular is looking to break into quant trading. And so when he asked me for a project idea that will help him stand out relative to his competition, I brought up the idea of a code generator. Let's first talk about what sort of code he's generating before we go into how he's generating it and why he's generating it to begin with. Now let's understand a bit more about exchanges and what their relevance is in this code generation in order to understand the project and its purpose. If you aren't very trading inclined, you're probably not sure what an exchange is. An exchange is a platform in which people trade financial instruments. It's that simple. There's various different forms of exchanges, regulated to various extents. The large ones in the US are SIBO, CME, ICE, etc. Now, anytime you send information, whether it's an exchange or any platform online, you're making a conscious decision as to the format of the payload. Is it a JSON? Is it some other custom format? Anytime you send information to an exchange, it's usually in a custom format. And in this particular case on SIBO, it's a binary order entry format. And in order to explain what that format looks like, they have a certain specification which we'll be diving into. If you don't understand the specification, you're not going to understand the project and the purpose and the code generation. Now, let's take a step back and think high level. Anytime you send information online. In traditional web applications, the payload is usually JSON, right? So you have a key and a value, a key and a value, a key and a value. It's easy to serialize, it's easy to visually understand, and it's easy to pick up. Today's video is sponsored by me. I built this platform called getcracked.io, which focuses on everything outside of lead code for your interview prep. I built it because I noticed that there was a very large gap between what candidates should know and what candidates do know, which is effectively only lead code. As you can see, I have questions ranging from language knowledge and Rust, Python, C++, to operating systems, design patterns, etc. And these are questions that may come up in an interview, but will definitely come up on the actual job itself when you're out there writing code. If you're also competitive as well, there's a leaderboard where you can see how you rank against other people. Anytime you send a message, the disadvantage is that you are effectively sending over keys, right? So you are sending over X equals Y, J equals Z. And sometimes that could be inefficient. It can be inefficient because if you understand what the message type is, you don't need to continuously repeat the keys. I understand that the message type is a login message. The login message's first field is always your username, and the second field is always your password, yada, yada, yada. So what's the point of repeating those keys? That consideration is especially important in the world of high-frequency trading and low-latency development, because what's the point of spending more time to encode data if I already know beforehand what the message format's going to be like? In other words, I know the first value you're going to give me is whatever. The second value you're going to give me is always whatever. This is where we dive into the complications here, but I want to stress why it's important. These markets, guys, they trade based off of usually FIFO, first in, first out. So if you see a juicy opportunity, you want to be the first to wait in line. By being the first to wait in line, you are more likely to get the order that you are looking for at the price that's appealing to you. Now, various exchanges have their own order entry protocols, and they all detail that in this specification. Okay, now let's take a look at the specification now that we understand the background. So, we have a couple of things here: introduction, data types, etc. Let's take a look at an actual message format in order to understand the high-level design that they decided to take here at the SIBO. Okay, so they have different message types here. Now, every message type, you will notice, only includes values. Why does it only include values and not the keys like you would see in JSON? Well, because we know the exact ordering of data types, we know their length, and we know whether or not they're present. Okay, there are some optional fields. What do I mean by that? Let's take a look at an example. So every order entry message starts with a start of message, which is a binary identifier. This is the hexadecimal. So you're going to get BA. Okay? When you send, for example, data in JSON, you're sending it in the form of text. When you send it using a binary order entry protocol like SIBO's binary order entry protocol, you're sending it in hex. Okay, you're not sending it in string. In other words, you're sending it in binary. Yes, I know there will be people out there that will say, oh, well, a string is really just a binary representation of characters, etc. Okay, we get that. But what we're getting at here is if you on Wireshark, for example, the average person was to dissect this message, they would see simply hex. They would not see strings. So it would be very hard for the human eye to understand the contents of this actual message payload. Okay. Now, you're probably wondering, how do I know what the type of the message is? Well, after the start of the message and the encoding of the message length, which is always 2 bytes, you're going to get the message type. So starting from the 4th byte, spanning 1 byte, right? So starting at the 4th byte, that 5th byte will tell you the message type. And in this case, new order cross messages are always a message type of hex 41. That represents something else in decimal, but hex 41. Okay, now every single one of these messages are going to have a couple of fields. They will have mandatory fields, they will have group fields, they will have optional fields within those group fields, and they will have optional fields. Let me break down what that looks like in the CBOE's protocol. So every new order cross message is going to have a cross ID, which is a text. It's a text of length 20. It's going to have a cross type, starting at the 30th byte, of length 1, alphanumeric. It's going to have a cross prioritization, which will be either a buy or a sell, 1 byte to encode that information. It's going to have a price of type binary price. The data type binary price is detailed earlier on in the specification. It's going to have an order quantity. All that makes sense so far. These are all mandatory fields we need to have that all have a specific length. Order quantity, for example, will be of binary type, and it'll always have a length of 4 bytes. Okay. Now we get into some nuances or specifications that aren't so obvious. Number of new order bits. What does this mean? Sorry, number of new order cross bit fields. What does this mean? Well, you also want to encode optional data. For example, let's take a look at some of the optional data we have here. At the very bottom, it says optional fields, and there's actually an example here, which we'll get back to soon, but I want to take a look at now to solidify this. One of the optional fields is the symbol that you're trading and the target party ID. These don't have to be a part of the message, but if they are, the SIBO needs a way to signal, and you need a way to signal that they are present, that you would like to include them. Okay? So how do you do that? You do that with the bit field, or with several bit fields, each bit field encoding a separate optional field's presence or absence. So as you can see here, number of new order cross bit fields. This is a mandatory field that will tell you how many units of additional optional keys might you have. Here we have 2 bit fields, meaning the first bit field is going to encode specific information related to optional fields, and the next bit field is going to encode specific information related to optional fields. Let's take a look as to where we can actually see in the first bit field what we can expect to either be present or not present in the rest of the message, and the same thing in the second bit field. New order cross. Okay. We saw in the previous example that the number of bit fields was set to 2. Okay? In total, new order cross has 4 bit fields. But in that message, information only pertinent to 2 were included. That being the first bit field and the second bit field. Okay. The first bit field will contain information like symbol, maturity date, put or call, exec ID. The second, CMTA number, clearing account, routing ID, clearing optional data. Now, what does this really mean? Well, if there's 2 bit fields, and in the first bit field, if that first byte has its lowest order bit present, in other words, the lowest order bit is set to 1, then that means you can expect that the symbol will be present. The symbol will either be present in an optional field at the end of the message, or as part of an optional field in the group, and we'll get to take a look at what that means in a second. In the message above, that message example that we saw, symbol was the last field that was optional as not part of a group. So if symbol is active in this bit field, it means at the end of the message, as the first optional field, you can expect to see the symbol. Now, we also saw that as part of the group, there's an optional field called CMTA number. If in the second bit field, the 5th lowest order bit is on, that means that the repeating group will definitely contain a CMTA number. Let's go back and take a look at what I mean by repeating groups. So we just talked about optional fields that can be included in groups or can be included at the end of the message. Let's go all the way back. New order cross message example. Let's continue. We just took a detour related to bit fields and how they can encode the presence of optional fields. There can be between, I guess, 1 and n bit fields. The number of bit fields, though, is constrained by the maximum size of a single byte. In this case, if it's an unsigned byte, you can have up to 255 different bit fields. Okay, now let's take a look at what a group is. Just like we encode the number of bit fields that will be repeating in this mandatory message, we will also get a group count, which could be between 0 and some other number. In this case, it says must be at least 2 and no more than 11. So you're definitely going to have a repeating group in this message. A repeating group is exactly that. You're going to get the number of repeating groups and then the structure of the repeating group. So in this case, side is always there. Allocation quantity is always there. Client order ID, which is a 20-character text string, will always be there. Capacity, open, close, etc. But now we see optional fields like account and CMTA number. These may or may not be part of every repeating group. Now, what does that mean? It doesn't mean it could be in one repeating group and not the other. It's either present or it's not. And how do you know whether it's present? Well, we go back to our bit field. Account is in the second bit field, as we previously saw. If it is present, if that bit is set for account, it will be present in every repeating group as part of this message. So let's take a look here. As we can see in this example, we had 2 bit fields. The first bit field said that symbol and target party ID will be active. The second bit field said that CMTA number and clearing account will be active. CMTA number is an optional field in the group. And as a result, when we go to the group, we see the mandatory field side. We see alloc quantity, client order ID, capacity, and CMTA number and clearing account. Now, why does side show up again? Well, in our group count, as we can see here, it specifies that there will be 3 repeating groups. Okay? There's going to be 3 repeating groups. So we're going to see side once, side twice, and side a third time. Now, let's take a step backwards and try to envision dozens, potentially hundreds of different messages, all with their own custom format. Now, imagine you as a developer need to write parsers in order to parse all these different message formats and then be able to use those parsers, the decoders, the stream operators, the helpers, whatever you're using to encode and decode these messages to be able to send to these exchanges. Now imagine you don't only have to do it for SIBO, but for ICE and CME. You can see how that becomes really problematic, especially when they version these protocols and specifications such that they change different things. So they might, for example, change no unspecified unit replay, right? They might remove it from the login request message. If they do so, well, you don't want to have to go in and edit every single thing related to login message. That's not tenable and it's not scalable. So what the Discord member, the person that submitted this, did is they wrote a code generator in order to take these messages in a given more generic format and write the parsers, write the encoders, decoders, helpers, etc. Now let's take a look at this person's project. So now that at this point we have a better understanding of what the purpose of this sort of application is by virtue of looking at the actual problem at hand, let's take a look at his GitHub repository and then we'll go into the code. I'll pull up Visual Studio, etc. So about a low latency C++ generator inspired by Fix8, creating encoder, decoder, and message classes from a custom YAML schema for binary order entry protocol. Lightweight and flexible, it supports constrained optional fields, repeating nested groups, and versioning without the complexity of a full fix engine. All right. The bulk of understanding this project is understanding the YAML structure and understanding the purpose and some of the details related to the code generation. Binary order entry protocol, really long name, pretty cool. He has project documents which are really cool that talk about the problem statement, business overview, and technical deep dive. He really details the key features about error handling, etc. He talks about the usage, which is great. Too many people don't tell you how to run their code, and you have to end up spending 20 minutes sifting out how the hell they want to run it. There's no make files, there's nothing. Project structure, that's great. He details very clearly where the Jinja templates are, which we'll get to in a second, why the code generator, formatting, etc. Now, a lot of you guys are going to see this README and say, well, this looks AI generated. There are components of this project that are AI generated where it makes sense. So I spoke to this person on an actual call. I know him quite well as a Discord member. And he said, yes, some of these parts are code generated, but a lot of the actual code is not. The code generated parts are things like the README, right? Hey, ChatGPT, here's what I want you to communicate. Here are the documents you need for the links. Here are the features. Here are the usage patterns. Can you please generate me a README that'll make sense for a user? Sure, that's fine. Go ahead and do that. Everything, and I want to stress that everything that he coded, everything in source that's related to code that's pertinent to this project, I've asked him about and he's been able to explain. So it's not like I don't know this person, they're submitting some AI slop and I'm just reviewing it for the fun of it. So I had questions. I reviewed those questions because I wanted to make sure that I'm giving you guys the best possible code review. And I went on a call with this individual to make sure that he actually knows what he submitted and can answer my questions. Let's take a look at the source. Okay. The source is obviously where the code is. And then there's the docs. If you're new to a lot of this, you want to go to the docs. This is very well written. He talked about his problem statement, the technical overview, the business overview. If you have any questions about what I said, sometimes I speak fast and maybe I didn't go into enough detail, this technical overview will give you a really good explanation as to the decisions that were made, why he decided to do this, how he decided to do it, etc. Okay, that's this technical overview. Business overview is, I'm not so technically inclined. I don't really care. I'm a project manager. I'm a software engineer that doesn't really care about anything related to trading. I'm going to look at the business overview. And the problem statement is exactly what we just went and discussed about. Okay? Let's now take a look in Visual Studio. So I need to make this a lot bigger for you. Okay. We have a source folder, common, templates, temp, etc. Temp here includes all his project ideas, all his notes, everything that were kind of the earlier iterations. We don't need to care about it to understand this project. Then we have two things that are going to be the utmost important: the Python code generation from Jinja and the YAML file. Let's talk about a high level what he did here before we get into the actual specifications of the YAML and the code generation. So there's something called Jinja. It's a code generator. It's a code generator that's often used for HTML, but you can really use it for anything. Now, in order to generate these messages in a way that's scalable, you need to automate them. And so he decided to use Jinja as a tool to do so. Now, as part of that, I want to show you what Jinja, what the inspiration for his Jinja is, or his Jinja usage rather. So if you look here, this person built a project. This guy named Mark's Software Blog built a project in which he specified a given message type, the name of the message, and fields. And he used this YAML template alongside Jinja to generate a header file and the implementation file based off of this information. This document, which I will link in the description box below, you can read into to give you a better understanding of how to use Jinja along with Python in order to generate code. Now, that means that a lot of the heavy lifting for this developer was understanding the CBOE's binary order entry protocol very deeply, and then generating the YAML and thinking about how to generate the YAML that will give him the exact structure that he wants for the messages that he would like to generate. So let's take a look at how he did that given our current understanding. And once again, guys, high level here, and then we'll go into the details. So he wanted to support at the beginning, for the sake of this project, right? This is a proof of concept, two message types, the login request and the new order cross. We just looked at the new order cross. And so we're going to look here and look at what this new order cross is actually doing. Let's start with the field. So he's specifying the fields. Start of message. So what is start of message? It is of start of message enum type, and the value is a data type. Okay? It's a enum of data type uint16t. And the value in this case is BABA, as we previously saw in the CBOE specification. Okay. After we have that, the next is the message length. Then the message type. Message type is new order cross. That's hard coded. Okay. Okay, Vim is being weird here. New order cross. That should be part of the enum right here. New order cross. Remember that value, 41? That's the exact message type here. Okay. Message length, what's the type? Well, the type is actually encoded later in this document. So the type for message length is always going to be uint16t. So as you can see here, anything that might have a different value other than the value explicitly associated with the key is given its value as the value here. But we know that sequence numbers across messages will always be the same, right? So sequence number, data uint32t. In this case, he wanted to give it a specific value as part of an enum. Okay, my Vim's being weird here, so I have to be a normie. Yeah, sequence number 0. So effectively, it's always going to be defaulted to 0 in the login message. And that makes sense, right? Because it's a session layer message, not a business layer message. One of a range of different values that are specific for this message are detailed in a list. And then we have the rest of our mandatory fields. And now we have our bit fields. So number of new order bit fields is a parameter group. And the parameter group's type is number of new order cross bit fields. That's a bit confusing. And that's something that I would like to address in this code review. Oftentimes, he's reusing the names of data types because these two types have the same underlying data type. What do I mean by that? Well, seeing number of new order cross bit fields makes sense. We saw that in the previous message. In that case, it was 2. We know it's a grouping, so it's going to be a repeating field. A repeating field of what? A repeating field of really just bit fields, not number of new order cross bit fields. It just so happens that bit fields and number of new order cross bit fields have the exact same underlying type, uint 8t. So he decided to repeat it here, but for the purpose of readability, it's a bit confusing. Group count, we've seen before, and then the potential either optional or non-optional fields in the actual grouping. Okay. Now we also, above and beyond messages, right? Let's close that. Now we define our groups. Each message can have one or more groups. So here we're defining our groups. So each repeating group of new order cross is of type has side, has alloc, has client order ID, everything we've seen previously. Then it also has these optional fields. Okay. We also have a metadata field here, which is associated with a bit field. Okay. Then we have number of units. We have the entire layout here. Now, for the optional fields, how did he map that bit field to the actual optional fields that we saw previously in the CBOE's specification? As we can see here, optionals for the new order cross message, right? Optional new order cross message. Everything in the first bit field 0. The first bit in that 0th bit field is symbol. The next is maturity date. The next is strike price. So you can see there's a very clear mapping between his YAML file and the CBOE specification. Then we have enums with their fixed values and their underlying types. And then we have fields. We previously saw, for example, that client order ID, I believe, was a length of 20, right? Cross ID was a length of 20. So it's a char pointer of length 20. Those of you that were more astute and paying attention at the beginning were probably thinking, how did variable length fields work? Because when I send a JSON payload and it has a string, it can be of length 0 or length 100. Well, in the binary order entry world, every string is a string of length X. So cross ID is a string, but it's a string that will always be at most 20 characters. It could be 2 characters, but at most a 20 character string. And if it's only 2 characters, the rest is just padding. It's just empty space. Okay, now that we understand the general YAML structure, and I'll let you guys dive into it a bit more because I want to keep this moving, let's take a look at what this YAML structure is doing. So this YAML structure is coupled with Jinja. Jinja is using this YAML structure, as we've seen here, the YAML structure with Jinja in order to generate implementation and header files. So here's an example, which is very similar to the example that he wrote in this Python code. He took inspiration. And what he's doing is, opening the YAML file, getting the details from the configuration name. As you can see here, CBO, BOE. This looks like most likely a date or a versioning. Yeah, not as clear what exactly these numbers are. Let's see here. Oh, yeah, it is a version. My bad. A version. And then he's going ahead and following the exact same structure that Mark here used in order to write header files, which I'll show you in a second, using Jinja templates. Let's take a look at the output, and then let's take a look at the other part of the input, which is the Jinja files. So if I go to, nope, that's the Jinja. Yeah, if I go to the output of all this Python code, it's going to be this, right? So C1, BOE, and the version. All right, what is C1? C1 is the exchange, the protocol is BOE, and then the version. Now, the output of this is 5 files in particular: decoder, encoder, handler, messages, stream. Let's take a look at messages first. This is the decoded output of the messages as represented by SIBO in the specification document. So, as we can see here, we have a string length enum. So it's saying for any username string, it's going to be 4 characters, cross ID string, 20 characters, right? We saw that previously right here at the end of this YAML file. Once again, high level here. We don't need to go too crazy in depth, but the client order ID, for example, the cross ID, that length of 20 is now reflected in an enumeration, right? Length 20 for cross ID, length 20 for client order ID. The actual new order cross bit field index. So which bit field can I find symbol in? I can find symbol in the first bit field. Which index does symbol belong to? It belongs to index 0. Okay. Message enums, new order cross, the human readable base 10 representation of that hex 41 is 65. Now we move on to the generation of message enum options. So 55, right? Always associated with login response. So we're mapping between the number and the enum, and here we can get the enum to the number. I think that all makes sense so far. Now we get to the actual bit field section, right? So group of new order bit fields, we always know that it is 1 byte, and this represents the number of bit fields, and we can return them or set them. When we are encoding, for example, we want to be able to set this. So we have methods that have been auto-generated that set this value for a group of new order cross bit fields. Then we can get either a reference to or a copy of this bit field. I don't understand why you'd ever really need a reference to it, especially when you're decoding, but he wanted to go ahead and generate that method. No issue there with me. Now let's look at the repeating group. So what he decided to do for the repeating group is anytime there was a value that was an enumeration, he decided to specify the enumeration publicly. And then anytime there is a value that is not related to an enumeration or already a predefined data type, like an array of whatever or a uint32, was in the private field. All right, so public enum that he can then use to encode or set, and then the actual private backing field. As you can see here, all the fields that you can expect in that message are present here, even the optional fields. These optional fields, if they aren't present as being required by the bit field, they will just be empty. Now you're probably wondering, well, this is still going to take up whatever bytes the count is, 16 bytes. How does that work? Yes, this will allocate an array of 16 bytes, but when I'm encoding this, if a count is not present, I'm going to skip the encoding of a count into that binary message. Likewise, when I'm decoding that binary message, if a count is not present, I will not fill out this account array. It's just going to be empty. So the actual in-memory C# data layout will be larger than the binary layout on the wire that's being sent, simply because it has to accommodate the possibility of a count being present. And to do so, we have to have an array of 16 bytes in the actual C# object. Sorry, C++ object. I wrote a C# code generator before. That's why I'm mixing up the two. Okay. As you can see here, a great job in generating the group. So anytime I have a side, an alloc quantity, right? These are all mandatory fields. And then we have our optional fields. So obviously, if it's not present, this will just be an empty string. And we can also call various methods on it. Reset, which will fill the entire thing with 0. We can make the enum unknown. We can get a copy or reference to really any field we'd like. We can set any field we would like. That's really cool. A bug. This is more the low-level details. Previously, in another code review, I had somebody critique me for going too in-depth in the low level and not enough on the high-level design. Now let's talk about the low level, because I went and reviewed almost every line of this generated code, and I noticed that there's an issue here. Side enum options is a static member of the new order cross. Let's go ahead and find it. So it's a static member of the, repeating group of new order cross. Now, if this is a static member, in order to initialize this side enum options, you need to scope this side enum option definition with that class name. In other words, I need to do like group, whatever it is, repeating new order cross. I need to scope it and then do, what was it? Capacity or side, I need to do that. That's the only way to actually define that define that static field in the class. If I don't have this scoping, I'm not going to get an error. I might not even get a warning. I will just declare in the scope of this entire class or namespace that it's in, a data of an unordered map that is called side enum options. And when I will try to reference side enum options as part of the static member of the class, it's going to give me an error. It's going to say if I'm, I'm pretty sure the compiler will emit an error. It won't be a runtime error, but it'll say you're trying to access a field that is uninitialized. Okay. What he can do instead of doing this is either, like I said, scoping this so that it's associated with that static class level data member, or simply defining this as inline in that class. In C++ 17 and beyond, you can actually define a static member in a class as long as it is an inline static member. We have other data types, group number of units, etc. I think you guys are starting to get the drift here. Once again, all this code's public. You can take a look at it yourself. He also generated the streaming, the streams here. So effectively overloads for the ostream operator for all the length, for all the arrays. Okay, for all the various generated code types, group number of new order cross bit fields, group repeating group. So the side, print me the side, the alloc, print me the alloc quantity, etc. Okay. Now we have handlers and we have decoders and encoders. Handlers usually either run during encoding or during decoding. And then we have encoders, which will take kind of the binary version, and then templated will go ahead and decode that message. So we have a lot of specific message examples here. We have the login encoder. We have an array encoder. We have the, let's see here. The one thing that I would change here high level as well as the code formatting is not great, as you can see. I'll show you in a second, but we have the encoder for the group number of cross bit fields. Yeah, you can see here the code formatting is kind of throwing me off. We have encode that's super tabbed out, and then we have one that's fine, and we're missing a space here. Anyways, these are our encoders. Okay, we'll take a look at an example usage in a sec. We also have the encoding of the bit field groups and the repeating groups. Now, another piece of information that is more low level, that is a small design decision that should be changed, is when we take a look at the Jinja templates, you'll notice that for every first bit field object, he specifies the index of it as being 0, which doesn't really make sense because he's specifying bit field index 0, and then he's getting the bit field index from where he should be, which is the new order cross bit field index. So in other words, it's superfluous. Like you already have 0 here, right? Bit field index, the group index. You don't need to have this here again just for the first field. That doesn't make sense. And then we have obviously the bit index within that first bit field, which is also the 0th index. Cool. Here he's just checking for whether or not this symbol exists in the requisite bit field. And if it does, he's doing the encoding. All right, now let's take a look at Jinja, the template. So Jinja's actually quite new to me. With the way that I did it did not involve Jinja. I did it with an XML instead of a YAML. But I think that the YAML is actually a lot cleaner and cooler. I don't really like working with XML. So let's take a look here. So for every single file that he generated, for every .h file, he has a requisite Jinja template. So messages, for example. So let's go all the way to the end here. And we can see every single, or the end message header file will contain these fields, and then it'll run, give me the string length enums for the YAML data and fields. Give me the optional enumerators for YAML data and options. Once again, that directly responds to the string length enums, right? The optional fields. He's generating the required bit fields, and he's doing all that with his Jinja template. Enumerators, groups, and messages, okay? I can go into these details with you, but I think that'll be a bit of a slog. Effectively, for every data item in the optional enumerators, he's going to get the key and the associated values. He's going to generate, from the key, a bit field index enum. So for example, if we go to the YAML, you go to the optional enumerations, right? So the key, new order cross, and then the bit field values. So let's go ahead and take a look. Yeah, new order cross, right? And then the bit field values. And he's just going to go ahead and based off that YAML file for these, iterate over that and generate those enumerations. Same thing for enums, etc. And that'll generate this code. One small nitpick I have with these Jinja templates is that nowhere here does it say that any of this code is auto-generated. So once again, this is more of a smaller detail, but anytime somebody in a group organizational setting is going to be looking at this code, they're going to be tempted to actually edit it by accident, unless at the very top of every generated file it says something like, you know, do not touch this, it's auto-generated. Okay, so that's something that I would change if I could. Something to also note about these templates that I noticed is that you're including the hard-coded path to your common directory that includes status and utils. You know, obviously here, root, subhash, that's your name. Make it a relative path. There's no need for this to be hard-coded with your path, because that's going to make running this and testing this for another person a lot trickier. Now let's take a look at the test code that's been written. I'm in test.cpp now, and I'm looking at read hex payload from file at the very top of test.cpp. As you can see, he takes a file name, in this case, one of the files from his tests folder. And here we have login request and new cross order. And these are both in hex. So these are hex representations of the information that should be contained in a message. He then reads that hex payload. The next thing he does is, as you can see here in main, so he reads the hex payload and then he calls process payload with the status. So we'll see how status is incorporated with the actual custom handler in a second, but he takes in a hex payload and a message type. What he's going to be doing is two things. The first is decoding that hex payload after first converting it to binary, right? So he goes ahead and decodes the hex payload after first converting it to binary. And then what he does is, given the message type, he will encode that message into a buffer that he will then later convert back to hex, as you can see here, and then compare it to the original hex string as found in the tests.txt file, right? So in this case, new cross order file, and the other one, login request file. Okay. Let's take a look at this little status object. So this little status object will contain information as to whether or not it completed successfully, whether it's currently being parsed, whether or not the object is invalid. And it does that with the custom handler. So the custom handler is part of boehandler.h. And what this will allow you to do is allow you to perform certain operations either during serialization or deserialization. So as you can see here, in this case, if we just call the parentheses operator, what it does is it just prints the info about the current status of parsing. And then with this operator here, it takes in the message and the status, and if the status is complete, it'll actually print out the entire message using the overloaded stream operators for that given message. So if the message is an array, it'll format it as such. If the message is a group repeating group of new order cross, it'll format it as such, etc., etc. Let's take a look at what we can expect from compare strings. So we have our original string and our encoded string. We print both, and if they're equal, well, we print them with an equal sign. Otherwise, we print them with an unequal sign. Okay. Let's go ahead and run the program. I actually needed to recompile this on Windows because the original test out was compiled on Linux and checked in. So I recompiled it on Windows, and when we go ahead and print new order cross with the message type 65, we get that they're equal. Now let's give it a random message type. Let's just say message type 12. They're not equal, which is great. We failed to encode the hex payload because the message type wasn't the one that we expected. Perfect. I like how he also has his utilities print, the 99 microseconds it took. We're printing the message as well. Remember, that's a custom handler that I spoke about prior, which is really cool. You can see in detail what the actual values are. If you guys like this project, I would make sure to reach out to Siv himself. I'm going to put his LinkedIn and his email in the description box below. Check out his work. Maybe speak to him if you'd like to collaborate. If you really want to talk to people that are on the edge of or tip of the spear with regards to looking to break into firms that are serious about not only quant but also software engineering, make sure to check out my Discord. Hopefully you guys learned a lot from this project. I know it was a lot, but I really want to make sure that I'm providing quality code reviews to you guys with projects that make sense for industries you guys are interested in breaking into. Alrighty guys, thanks for watching. Cheers.